Hey, good morning, everybody. This is Mr. Ainsworth, and we're in Algebra 1 here. We are going over some applications of systems of inequalities and throwing in some review in while we're at it. So let's get right in it. Okay, we want to solve each system by graphing. All right, we got a graph. Okay, so take a look at the first one here. Y is greater than or equal to 1/4 x plus 3. You guys, this is in slope-intercept form. Y is greater than or equal to mx plus b. So here the slope is 1/4 and the y-intercept is 3. And already, I just look at this right here. I'm looking at the inequality right here, greater than or equal to. And I know that dealing with a boundary line, it's going to be a solid boundary line. All right, BL is boundary line. And because this it's greater than, the solutions are above. All right, so you want to analyze things before you can get started. So start with a y-intercept of 3 on the y-axis. Use a slope of 1/4. All right, that's easy. Go up 1, right 4. Reverse that, go down 1, left 4. All right, and draw a line. There's your boundary line. Now, the solutions are above that, so just go ahead and represent that by a bunch of arrows. Okay, now the second one, let's switch colors here. The second one here, we have to get in slope-intercept form. That's one of the many techniques to do this. There are others, so if you want to do it other ways, that's cool too. All right, so first thing here, you're going to add the opposite with 2x, which is negative 2x. Okay, and I get negative y is less than negative 2x plus 4 because it's positive. I'm going to divide everything by negative 1. I'm talking everything here, all three terms. All right, what do we get? We get y greater than. We got to switch the inequality when you divide it by a negative. All right, negative 2x divided by negative 1 is 2x here. 4 divided by negative 1 is usually negative 4. So I have the slope and the y-intercept there. Okay, so now I'm looking at this inequality now, and I'm talking about the greater than symbol here. And just by looking at it, I know that the solutions are above the boundary line and not on the boundary line, so it's dotted. All right, dotted and above because we're dealing with greater than symbol. Okay, so start at negative 4. All right, slope of 2 is the same thing as 2 over 1, so we're going to go up 2, right 1. So up 2, right 1, up 2, right 1. You can see my points being plotted, up 2, right 1. They intersect right there at 4, comma 4. And then you just draw your boundary line. And I'm not going to draw it solid, I'm going to draw it dotted because the solutions are not on the boundary line. Okay, so there's the boundary line. Solutions are above it, all right, not below it, but above it. And what you guys have to realize in systems is that the solution to any system is an intersection. Okay, so let's write that out. Solution to the system, oops, solution to the system is the intersection or overlap. So intersection, you can think of that as overlap. Okay, so in this case, in my graph up here, where does the red intersect the blue? Well, let's highlight it. Okay, so it's in this yellow region right here where red overlaps with blue is above the red line and above the blue line where the red overlaps the blue. There we go. In a solution region A here, that's called the solution region. Solution region. In that yellow region right there. And any point in there satisfies both inequalities. That's what it means. Okay. All right. Now number two is different here. We got a boundary line. The y less than or equal to 1. If you go to the y-axis here and you find 1 on the y-axis right there, there's 1. All y values that are less than or equal to 1 are below that value. So we have a horizontal boundary line here. And all y values that are underneath this line are less than or equal to 1. So I'm going to shade down. Okay, all horizontal boundary lines are in that form. Okay, and then the other one, well, you got to do some homework, right? Okay, so we got to isolate y again, just like I did on the previous one. I'm going to add the opposite of x again. So I get negative 6y is greater than or equal to negative 3x plus 12. Divide by negative 6 on all terms. Simplify. Okay, so we have y greater than or equal to, nope, switch signs, or switch inequalities here, less than or equal to. So whenever you divide by a negative like I did on the first one here, you have to switch the inequality. 3/6 is 1/2 x, and then 12 divided by negative 6 is negative 2. So I see the slope and the y-intercept there. So I'm going to switch colors on the graph. I'm going to plot at negative 2, have a slope of 1/2. So I go up 1, right 2, up 1, right 2, up 1, right 2, reverse it, down 1, left 2, down 1, left 2, down 1, left 2. So draw your line. All right, and then you shade in the inequalities, and they're going to be below the boundary line here because, all right, because the inequality is less than or equal to. So anything below the horizontal line and intersecting red with blue is in the solution region. So you know what I got to do? We got to be careful here. I'm going to, I'm going to erase this right here. I'm going to extend the horizontal boundary line because it has to be below that, okay, not above that. So be very careful to the upper right. Solutions are underneath the horizontal red boundary line, underneath the blue line. Okay, it's where the red overlaps the blue. That is called the solution region. Any point in here is a solution to both inequalities. There we go. And we've been working on systems like this for over a week, so those are two of the basics there, and there's your warm-up right there. You should be good with that. Now let's reverse the process. If I give you the graph, can you come up with the system? Okay, and that's numbers 3 and 4. So let's go ahead and go through that. Okay, so now we got two boundary lines here, so let's just call them A and B. So boundary line A, and then boundary line B. So let's talk about the first one. Okay, so first of all, you guys have to know that this darker region here that I'm highlighted in red is your solution region. Now to make that happen, the solutions have to be above this boundary line. Okay. To also make that happen, solutions have to be below this dotted boundary line. Because remember, it's the intersection. So if you're above the solid line and below the dotted line, then you're in that red area. And that is called the solution region. Okay, so now what is this red boundary line inequality? What is that? Well, I know the solutions are above it, and I know the solutions are on it because it's solid. So what I need to do is I need to figure out the y-intercept and the slope. So the y-intercept here is at 1. The slope is up 1, right 2. Up 1, right 2. So I know my slope is rise over 1/2. I know it intersects the y-axis at 1. So the slope is 1/2. The y-intercept is 1. That means my inequality has got to be greater than or equal to 1/2 x, all right, plus 1. Okay, why? Because it intersects at 1 and it has a slope of 1/2. The solutions are above the line, so it's greater than. And we have a solid boundary line, so you got to have that equal to part. So again, this inequality here, above is greater than, solid means that they could be on the line. So you got to have that equal to portion. Okay, next one here, B. So I have a y-intercept of -2. What's the slope? It goes up 1, right 1. All right, so my slope is 1. My y-intercept is at -2. It's below the line though. Solutions are below the line, so I have to have y is strictly less than, all right, 1x minus 2 right through here. And so if you just simplify that, y is less than x minus 2. And there's my system. right there. These two together is called a system of equations, or in this case, system of inequalities. All right, so now 4, what I suggest you do is if you're watching at home, which you may be, all right, pause the video right now. Why don't you just try it on your own, and then when you're ready, play it, and then actually check your understanding, see if you actually understand it. Okay, I'm assuming you did that, so let's go for it here. So we have inequality A and inequality B. So let's take a look at A first. We need a slope and y-intercept. All right, so let's check it out. So the y-intercept here is obviously at 3. The slope from point to point, you got to go up 2, right 1. So the slope is, well, it's 2 over 1 or 2. Y-intercept at 3. The solutions are above this boundary line right here, as you can tell. Look at this shaded region right through here. So we have y is strictly greater than 2x plus 3. Okay, now how about the second one here? So for the second one, the solutions are below this boundary line. Okay, but I need to know the y-intercept and the slope. So the y-intercept is obviously at -2. The slope is right 2 down 1. So my slope is -1/2. My y-intercept, it intersects the x-axis at -2. The solutions are below the line, so y is less than or equal to -1/2 x minus 2. And there we go, we have our system. It's not that hard. Remember, the solution region is the dark region where they both overlap. And there's the first 4. There we go. Let's do one more here. So I'm going to cut up the video into 2 different parts. Let's do one more. Okay, number 5. Given the boundary lines of the system, shade in the solution region, then determine if each point is a solution to the region. Okay, well, we're given a system here. And the boundary lines are given, but not the shaded region. So here I'm looking at y greater than x plus 2. So that's the dotted line right here. So the one that's dotted is this one. Okay, and it's greater than, so we have to go above. So I'm going to shade above. Now the other one, I've got to do some work. Okay, so I'm going to subtract 3x here. I'm going to isolate y. I get y is strictly greater than or equal to -3x plus 6. And that's going to be the solid one right through here. So this is B here. The other one is A. And then it's greater than or equal to, so it's above. So I'm moving to graph above. Now, where does red overlap the blue? It's up here in this upper area. Okay, so in that region right through there. So you notice the 0.1 comma 6 is in the solution region. Okay, and if 1 comma 6 is in the solution region, that means it's a solution to the system. So I'm going to say yes over here on the left. And all these other points, 3 comma 2, no. -1 comma 3, no. -2 comma 2, no. They don't satisfy both inequalities. Only the points in the solution region satisfy both inequalities. And there you go. That's all there is to it. All right, so again, this is a video here. I'm just trying to help you guys online, depending on where you're at. Okay, you can always pause, play, and rewind and take a look at it here and use the video to your advantage. And that's part 1. In part 2, I'll solve this problem here. So if you need that help, go to the next video, and I'll see you there. All right, it's Mr. Ainsworth here at Great Oak High School in the year 2025. 2025 at Great Oak High School. Here to help you out. You guys take care. Make yourself proud. I'll see you in the next one, and hopefully in class. Take care.